Hi, so welcome to this second lecture on analyzing requirements. So in the first lecture we looked at data flow diagrams and context level diagrams, and we looked at them in depth. So in this lecture we're going to look at the rest of the tools and methods that we can use to analyze the requirements after we have gathered them. So the first tool that we're going to look at are state diagrams. So basically a state diagram is a diagram that's supposed to show you the transition or the movements from one state to another. So these diagrams have got a state, then they've got transitions. So transitions are usually shown by the arrows, and then the states are usually shown by the vertices, which could be circular or which could be oval or whatever it is. So you'll find in this diagram you've got a state, for example, the state created, and then the transition is the arrow where something is happening which causes the movement from one state to another. So as we look at our application or our solution, we need to look at how it moves from one state to another. If it's a printing application, for example, how does it move from accepting the documents, then to putting it in a queue, to then printing it, and then to knowing that that job has been successful or failed, and it needs to either put it in a queue or remove it from the queue. So states basically show the various states that a system can be in, and then the arrows will show the transition or the actions that cause the change of state. And then within the states you can also analyze what causes the changes in those states. So understanding state transitions is part of system analysis and design. So it's important for you to understand how and why a system is moving from one state to another, okay? Because that helps you to know whether the system is operating correctly or not. Now, the reason why systems change always arise from events. So these events are different types of activities that occur that causes the system to move from one state to another. So you need to know the various events that will occur in your system, as well as the various states that your system will eventually end in, so that you are able to know whether you are getting the right results or not. So with these state diagrams, like we said, they are transitions. Transitions are showing the movement from one state to another. They show whatever has happened that has caused the movement from one state to another. So transitions can occur because an event occurred, or an action was performed, or because certain elements are in that source state. So when it's in a source state, then it's forced to then take an action so that the program can continue to work. Because if it's in the starting position, then something has to trigger it to start working, and then it starts producing outputs. So transitions are basically the arrows that are showing you the various actions that could occur as a result of an event and an action that has been performed. And then actions are the ones that trigger the movement from one state to another. And this occurs as a result of something that happens within that state. So there are 5 general triggers for actions. So when you're in a state, when on entry means when the system enters a certain state, a certain action automatically occurs. Do means probably when something happens, the system within that state is now supposed to take some form of action. And then on invent means when some event occurs, whatever the event is, the system is now supposed to take some action, which then triggers the change of states. Then on exit means either when the system is being shut down or when you're moving from one state to another, a certain action is supposed to happen. So this is an example of a state diagram for a washing machine. It's basically a very simple diagram. You should keep it simple. It should be very clear and should show us all the steps in a simple manner. So for example here, in this state, in the first state, the washing machine is off. So when it's off, you can either click the power button or you can click the power button. So if it's off, if you click the power button, it goes into idle mode. And then when it's in idle mode, and then when you click start, and the plan that you choose is regular, then the washing machine moves into the state of soaking, where it's going to do some light soaking, and then it's going to do some pump ins. But if it's in the idle state, and then you click start and choose the delicate or super delicate plan, it will skip the soak part and just go straight into the rinse part, where it's going to do a light rinsing and then a little stirring. Then after 30 minutes, it will, whether you have chosen the regular plan or the delicate plan, it goes into the drain state. In the drain state, it's either going to do a light drain or a pump out. And then based on which plan you have also chosen, if you have chosen the super delicate, then it goes back into idle. But if you have not chosen the super delicate, then it goes into the dry, and then it moves after 10 minutes into the idle. Okay, so you'll find that in this arrow, these arrows are showing some action that has been taken, which leads to a change in the state of our washing machine. So this is a simple state diagram that illustrates how states can help us to know how our system is actually functioning as it moves from one state to another. Then another tool that we can use for analyzing our requirements are class diagrams. So class diagrams basically are describing the structure of our system, and these class diagrams are showing us how the various classes of that system are working together, how they interact or how they inherit from each other. Now you could use the unified modeling language to come up with a way of modeling these object-oriented systems and showing the relationships between these classes. So if we look at these class diagrams and the relationships that they show us, they generally show us how the various systems inherit from each other. So they're showing us the inheritance relationship as well as the interface implementations. Then they also show us the dependencies between the classes, the aggregation between the various member functions and whatever outputs of those classes, as well as the composition of those classes. So this is an example of a class diagram. So a class diagram is the lines are showing the connection between the various class diagrams. Each rectangle that is yellow is showing a class. So we've got the student body class that only contains the main argument, which is the main method for running the application. Then we've got the student class, which has got certain variables like our first names, last name, and those have got certain data types, and the data types are the string, as well as our home address variable, which has got the data type address. Then we also have the address class, which has got certain variables, which are of the data type string, and the zip code, which is the data type of long. So we can now see that the connection between these is that the student class has got variables, which are the home addresses, but these are actually data types or derived from the class address. So this is showing the connection between our various constructs in our program. This is also another class diagram which is showing the inheritance relationship between various classes. For example, the assignment class it can inherit the course class as well as the exam class. They can inherit from the course class, and the course class has got a relationship with the department as well as the textbooks. So that's basically what class diagrams will show you. Then we also have decision trees. So decision trees help you usually with an what if or with an if analysis. So if you are doing an if analysis where you end up having two or more options to choose from, then a decision tree can help you with that. For example, if age is X and income is Y and the family size is Z, then the credit spending is P, then you accept the loan. So there are certain conditions that have to exist for age, income, and family size and credit card for them to accept the loan. So this is a very simple but very powerful way of coming up with the decisions and analyzing how your system is going to make decisions as it processes the inputs that it receives. So this is another example of a decision tree. So for example, George's garage is hiring a mechanic. So if George hires a mechanic, it's going to cost him 50,000. If he doesn't hire a mechanic, it's going to cost him $0. But if George hires a new mechanic, that means if he hires a new mechanic and if there is a 70% of chance of increase in accidents, then George will profit $70,000. But if he hires a new mechanic and there is a 30% chance of decrease in accidents, then George George's garage will only profit 20 minus 20,000, so it will actually make a loss. So based on this decision tree, George's garage can actually decide whether it's worthwhile to hire a new mechanic or not, given the various factors that are at play if they make one decision or the other. So the decision tree will always start from the root node. In this case, that's George's garage. That's the first and starting point. And then we move to the next branch. So we have got 2 branches, hire new mechanic or don't hire new mechanic. And then from one branch, you can move to more branches. And each branch has got 2 or more options. So as you make decisions going down, your leaf nodes are either 2 or more, so that they are always options that you're supposed to choose from. So that's what a decision tree can help you to. It can help you to decide on which option to choose given the various options that are at hand. So when do you use the decision tree? It's basically best used when the target function is discrete. So you know that your values are not continuous, but you've got clear-cut values. For example, it's a yes or a no, it's a 1 or a 2. So your values are very clear, and it makes it simple for you to make those decisions using the decision tree. Also, where they are missing attribute values, you can also use that. So the decision trees can be used where they are in medical diagnosis. For example, do you have a tumor or not? Yes, I do. Is the tumor red or blue? And then, have you ever been operated before? You know, if you go down that chain, even with credit and risk analysis, you eventually have all the factors that you need. And then based on the ways that you've put, you can come up with a score, and then you assign that score and make a decision. So that's basically what decision trees work like. Then we have decision tables. So just like decision trees, decision tables help you to make decisions given the various options that are at hand. But unlike decision trees, decision tables, you've got rules. So these rules specify the kind of actions or the kind of environment that are available given the set of conditions at play. Then you've got the conditions themselves, you know, the various conditions that can exist, which variable can exist with which variable and at what level. Then given the rules and those conditions, there are actions that also can be taken. So it's basically a combination of three elements that should work together at the same time to produce something that's workable. So this is an example of a decision table. Okay, so we can look at the decision table on the left, and you can see that it's got rules. The rules are so S stands for salaried. So this is a decision table of employees and whether they are salaried or they work on an hourly basis. So S will stand for salaried, and H, they will work on an hourly rate. So the first rule is a person is salaried and they work less than 40 hours. So if this condition exists that a person is salaried and they work less than 40 hours, so the rules are salaried, hourly, salaried, less than 40, greater than 40, etc. So if we say the condition is if a person is salaried and works less than 40 hours, then what do we do? These are the actions that are taken. Then we just pay them the base salary. If we take rule number 5, if a person is salaried and they work greater than 40 hours, if you're salaried hours, no matter how many hours you work, you still get paid your base salary. But if you're an hourly worker and you work more than 40 hours, you get your calculated hourly wage plus you get your overtime. So these various conditions now will help you to make a decision on what action to take based on the information at hand. So that's how a decision table would work. So an activity diagram is like it's like an inverted state diagram. So where a state diagram, we are talking of, we have got our vertices as our states, and then the edges, which are arrows, are showing us the action that has been taken for us to move from one state to another. With activity diagrams, the vertices now, the rectangles, the oval shapes, are now activities that have happened, and the arrows are now the various states that have arisen as a result of that action, and then the arrows are representing the states that the system is going into as it moves from one action to another. So basically, activity diagrams are showing the sequence of activities in a process, and they are showing the sequential and parallel activities and the decisions that are made. So at times, certain activities can be done in parallel, and certain activities need to be done in a sequential manner. So when you're creating your activity diagrams, you need to ask yourself what happens first, because we are creating a collection of actions, and we have to know whether they are sequential or they can be done in parallel. So you have to know the order in which they happen, and you also can get those activities from your physical data flow diagram. So if you look at a data flow diagram and you look at the various processes, they can actually tell you the various actions that are being taken by the system. So this is an example of an activity diagram. So an activity diagram, for example, in this one, you perform the first activity, whatever that activity is. Maybe it's take customer order. Then from there now you have to decide, you can move into a fork where after taking the customer order, you can take it straight to the kitchen and then deliver to the customer. Or after taking the customer order, you have to decide whether the order is a sit-in or it's a takeaway. If it's a sit-in, then you create the food and then you take it to the customer. If it's a delivery, you prepare the delivery and then you take it to the customer. So the activity diagram is showing the activities that you take based on the various inputs that are available, and also showing whether these events can be done sequentially or in parallel. And an activity diagram is like an inverted state diagram, where with state diagrams we focus on the states, but with the activity diagram we're focusing on the activities. Then we have sequence diagrams. Basically, sequence diagrams, also just like activity diagrams, they are trying to show us how various classes or objects, instances, interact over time. So sequence diagrams are good for object-oriented program analysis, and they are used to show the processing described in use case scenarios. So if you've got a use case scenario of how something is going to be used, sequence diagrams will help you in that they will show how the various objects are instantiated, coded, and used, and the various return values that are also used there. So this is an example of a sequence diagram. So we have got our object, our class. So with a certain method code, we create maybe the object class, and then we return a certain value or the object itself, and then we do some action under a synchronous signal method, and then that in itself updates that object. And then here we don't have any other action that happens, so we terminate the program. So this is basically showing us the sequence of how the various classes and methods and variables are coded and used within an object-oriented program. This is also another example of a sequence diagram. So it's showing us, it's for student admission. So it's showing that you initialize the program, you've got a new student, so you create a student, then you return that student's number. So you now have a registration number for the student. Then the program then selects a dorm for the student where they are going to sleep, and then it returns the dorm room to that new student interface. So the student now is a student number, they now have a dorm room, and then after that they select the program that they're going to be done, and then they're going to be doing, and then the program returns the program advisor. So now the student has got a student number 1, then secondly they get a dorm room, and then thirdly they get a program advisor, and lastly the program ends with the completion of the creation of the student and their details. So this is showing the sequence of how the various modules of our new student interface, the student class, the dorm class, as well as the program class are coded, and the values that they return to the user interface for the new student. Then finally, we have got use case diagrams. So use case diagrams also sort of resemble a simplified data flow diagram. So they are basically trying to show us the relationship between external entities, which are called actors in this sense, and the various functions that the system has. So in the simplest form, you could call a use case diagram is basically showing us the list of functions that a user can use in that system. So if you look at this diagram for a castle, the system has got car ordering function, car handover function, business monitor function, and payment checking. And the actors in this instance are the salesman, the accountant, and the manager. So for the car ordering use case or the car ordering function, the user of that is the salesman, and the salesman is responsible is the one that requires the car ordering, the car handover use case. So those use cases need to be taken care of in the system by actually creating those modules. And then the payment checking is done by the accountant, as well as the business monitor being done by the manager. So this is a simplified diagram just showing us the various use cases for a car sales system and how the system is used by various people or actors as they do their work. So this is basically just explaining who is an actor. So basically an actor is like an external entity, someone who is going to use the system or another system that integrates with that system and takes any outputs from that system. So basically this is these are some of the methods that you can use to analyze requirements on top of data flow diagrams, and they are also helpful and used in different settings or different environments depending on the requirements. So thank you for listening to this lecture.